Alright guys, so cosecant, if you remember, cosecant is the reciprocal of sine. So when you're talking about the graph of cosecant, it's very much related to the graph of sine in that I'm going to always start with a sine wave and then go from there. Okay, figure out what the graph looks like using the values of sine. Okay, so first off, let me just graph a regular sine wave from negative 2 pi to 2 pi. And that's what I would expect you to do. So on that graph paper that I gave you yesterday, okay, so you got your basic sine wave. I'm going to do this in a light color so that I can see over it when I draw the graph of cosecant. So sine starts at the origin, goes up 1, comes back down, goes down to the amplitude below, and then back to the midline. And then it just does the opposite on this side, as we know. Okay. So my sine wave looks like this. Okay. So then let's talk about values of cosecant. So cosecant is just the reciprocal of sine, right? So right here, when you have sine is 1, then cosecant would be 1 over 1, right? Which is 1 as well. Down here, you've got negative 1. Cosecant would be 1 over negative 1, which is negative 1 as well. So all of these 1 and negative 1 values are the same in cosecant. Okay, so those are repeated. If you think about it like right here, let's see, sine at pi over 6 is 1/2, which would mean cosecant of pi over 6 would be 2. Okay, so at pi over 6, which is somewhere in here, if this is pi over 4, pi over 6 right here, where this is 1/2, this would be 2. And again, sine is 1/2 at 5 pi over 6, which is just a 1/6 pi, or 30 degrees away from pi, 180 degrees, and that would also be 2. Yeah. And then down here, where sine is negative 1/2, that means cosecant would be negative 2. So at 7 pi over 6, which is halfway between, or not halfway, it's a third after pi, you would be down here at negative 2. And then again, you would be at negative 2 down here. So far what I see is I've got this point, this point, and this point. This point, this point, and this point, okay? And then you got right here, at 0, sine is 0, right? Which would mean cosecant of 0 would be 1 over 0, which is undefined, yeah? Well, think about it this way. As sine gets smaller, cosecant, which is 1 divided by sine. Well, if you divide 1 by an increasingly small number, then it actually gets increasingly large. So in fact, cosecant does this. Because everywhere that sine is 0, cosecant has a vertical asymptote. And so we've got a vertical asymptote here, and a vertical asymptote here, and a vertical asymptote here. And just like this right here, this is going up, so this is going down. So we've got this right here. So you got this shape over here and then this shape down here. And then in this case, it does the same thing, it repeats itself. And I don't necessarily need to see these 2 points that I'm drawing. I'm just showing them to you so that you can have another point to draw. But on your on a regular wave, I would be okay with you just kind of drawing these hills and valleys. Okay? So in general, whenever I think about a sine wave or a cosecant wave, I just think, well, let me draw a sine wave, and then where sine has a max, cosecant has a min. Where sine has a min, cosecant has a max. And you just do that. Okay? Alright, so that is cosecant. Let's talk period for a second. So period is the length of one wave. Well, so we did this, and then we did this, and right after that, sine would come up, so this would do it again. That means it takes 2 pi to repeat itself. Yeah, so the length of that. Okay. Vertical asymptotes. Looks like the vertical asymptotes occur at every pi. So I would say x equals n pi, where n is an integer. Domain. So domain will be all real numbers except n pi, where n is an integer. I don't know why I did that, but whatever. Range. So range is actually kind of interesting on these. So it goes all the way down and it goes all the way up, but it does not go. It has a gap in the center of the function, right? So my domain would actually, or my range would be negative infinity up to -1, and then from 1 up to infinity. Or you could say y less than or equal to -1 and y greater than or equal to +1. Okay. X-intercepts. So x-intercepts, if you'll notice in this case, there aren't any. And the only time you would have one is if you stretched or shifted it up or down, and unless it was these maxes and mins, then I wouldn't expect you to find them. Not right now. Y-intercept, in this case it doesn't cross the y-axis, so none. And did I see anything else on? Oh, extrema. Alright, so we have, let's start with this one right here. We have a min of 1 at x equals, okay, so this occurred at pi over 2, and then the next one would occur right here, right? Which is a width of 1, 2, 3, 4 tick marks away. So it repeats every 2 pi, so it takes a period in order for it to repeat. So I would say pi over 2 plus 2 pi n. Okay? And then maxima, we have a max of -1 at x equals, and so the first one occurred at 3 pi over 2. And again, it's 2 pi away. Okay? And that is cosecant. So again, when I want cosecant, I just think, well, let me graph sine, and then just go in the opposite directions. Okay? So now let's do secant, which is going to be very similar. So, you know, if cosine is just a phase shift of sine, then secant is just a phase shift of cosine. Or, sorry, of cosecant. So, cosecant is, or sorry, secant is 1 over cosine. So, let's graph the cosine wave. That's not 0. Pi over 2, pi, 3 pi over 2, negative pi, negative 2 pi. So a cosine wave generally starts at the amplitude, comes down the midline, goes to the minimum, goes to the midline, goes back to the max. And then symmetrical on this side. Now I'm just kidding. I'm just graphing from negative 2 pi to 2 pi on this one. And in this case, it's going to kind of split up the secant wave, which is going to be kind of interesting. But okay, so just like any other one, every time cosine is 1, secant is 1, and -1, secant is -1. So all of these points are repeated. And every time this has cosine has a 0, an x-intercept, secant has a vertical asymptote. So, okay, and then we sketch. So like I said, I mean, you know, these points are nice to have, but in general, I'm okay if you do something like this. As long as you have the basic shape that you're going to have a minimum where cosine has a max, and you're going to have a maximum whatever cosine has a min. That's good enough. So we've got these full pieces here. And then since, you only see this half of it, then you would only go up that half, and you would only go up that half. And so there you go. From negative 2 pi to 2 pi, that is what secant looks like. Okay, as far as like the information about it, period again would be 2 pi. The vertical asymptotes just occur at every pi over 2 plus pi in, and domain, all real numbers except your vertical asymptotes, range, negative infinity to negative 1, 1 to infinity. You don't need to write all this down. It's fine. This one does have a y-intercept, but that's okay. I think you've got the idea on that stuff by now. Okay, so let's actually graph a view. Describe the graph of y equals negative 2 secant of 3x plus 3. Locate the vertical asymptotes and graph on the window 0 to pi. Okay, so before you go and label, the fourth tick mark as pi, what you want to do is assess your period before you decide that that's what you want to do. I will go ahead and draw up 3 my midline, 1, 2, 3. Now in this case, your amplitude line, you can go back to drawing that, because you're going to have your cosine wave to kind of mimic or to kind of base your secant wave off of. So the amplitude is 2, so if I was drawing a cosine wave, then it would be this right here. Yeah. Okay. I'm going to draw my cosine wave out to the side with a period, and then well, actually I don't have a phase shift, so we're good. Okay, never mind. Okay, so the period on this would be 2 pi. We're back to 2 pi because secant has the same period as cosine. It's reciprocal. So 2 pi divided by b, which is 2/3 pi, which is an interesting one. So it's really nice if we can make 4 tick marks the period. So if I make this 2/3 pi, the question is, do I have enough room to get to pi? Well, if this is 2/3, then half of that is 1/3. And so if that's 1/3 and that's 2/3, and that's 3/3 right there, which is pi. So I have enough room. Okay. So if I need to figure out this tick mark, then I just cut that one half. Half of a third is a sixth, and then I just count by sixth. 1, 6, 2, 6, 36. 36 is 1/2. So 3, 6, 4, 6, 5, 6, and then pi. Okay. So from 0 to pi, I'm going to graph a cosine wave. I'm going to graph a negative cosine wave. So basically what I'm doing is I'm graphing this, and then I just use that to graph my secant wave. Okay? So cosine -2, cosine will start at the bottom, come up, go to the max, go to the midline, back to the bottom, back to the midline, and then back to the max, and then we're done, right? So my cosine wave would look like this. Which would mean that my secant wave, so if this one has a minimum, then secant has a maximum. And every time secant or cosine has a 0, secant has a vertical asymptote. So I go ahead and sketch those. And then we sketch the secant wave. So this is only a half of it because we're not graphing past 0, so it would do something like this. Over here you would have something like this. Over here you would have, and please make sure that you draw enough of the arc to go down to the vertical asymptotes, because I have some people that would just kind of do this, and that doesn't look like you're going to follow the vertical asymptote. And then on this side you would only see that. And there you go. That would be -2 secant 3x plus 3 on the window from 0 to pi. Okay? I find these more interesting to graph than some of the others. Okay, so one more. We've got 3 cosecant of 2 theta divided by 5 minus pi minus 2 from -5 pi to 15 pi over 4. Okay, interesting. So, I'm going to go ahead and go down 2. There's my midline. I think you can see it here now. Brighter color. Okay. Amplitude is 3, so I'm going to go up and down 3. I didn't leave myself much space out. That's okay. Wow, I didn't leave myself much space at all. I'm just kidding. We're going to change the problem. Let's make this 3 halves, just to give yourself more space to draw the wave. Okay. Let's determine the period. So period would be, period is 2 pi divided by b, which is 2/5, so that's 2 pi times 5 halves, which is 5 pi. Yeah? So, okay. I know I need to go from negative 5 pi to 15 pi over 4. I don't know where 15 pi over 4 is, so I'm going to have to figure that out. So what I'm going to do is, instead of drawing cosecant, I'm going to draw its reciprocal sine. I'm going to draw 2 waves of it. So 1, 2. And then obviously our cosecant would do this, right? So I'll sketch that in a second. So if this is 2 pi, and this is 4 pi, and this is pi, this would be a half pi. Okay, so then let me figure out what my force would be. So if this is 1/4, then this would be 2/4, and then this is 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Let's go. Also, remember you can just convert to force. So well, I should have just done that. So 2 pi is 8 pi divided by 4. 4 pi is 16 pi divided by 4. So if this would be 8, this would be 10 pi, this would be 12, this would be 14. So 15 pi over 4 is right here. Interesting. Okay. Again, I could keep going. 8, 9, 10, 11, 12, 13, 14, 15. Okay, and then, wait, why did I do that? Oh my gosh. That's ridiculous. Okay, well, I don't know why I did 2 pi, because we're not graphing on a period of 2 pi, so that was a waste of my time and yours. I apologize. Okay, the period of this sine wave is 5 pi. I don't know why I chose to do that. Okay, so this is 5 pi, and this is 10 pi, and this is 5 halves, and this is 5/4. So if this is 5/4, then this is 10/4, and this is 15/4. That makes more sense. Okay, so we are actually going to see, that's not perfect, but that's okay. We're going to go from negative 5 pi to 15/4 pi. Now that is without a phase shift, so let's go ahead and just we'll think about our wave right here. So I know that it should look like this, and like this, and like this, and like that. Without the phase shift, that's what my cosecant wave looks like. I'll go ahead and finish out my scale. So this would be negative 5 halves, this would be negative 5/4, and then that would be negative 15/4. Okay, so if I'm going to check my phase shift, but if this works out the way it is, then I'm just going to go ahead and do 1, 2, 3 tick marks is 15 pi over 4, and 4 tick marks is the period negative 5 pi. Okay, so phase shift is negative c over b, so that is a negative pi, which means positive pi, divided by b, which is 2/5, which is pi times 5/2, so 5/2 pi. So 5/2 pi is 2 tick marks, so that means we're literally just going to take everything and move it 2 tick marks actually to the right. Yeah. So this right here will actually be, this point would be 1, 2, it would be right here. Okay, so if I have that to draw, then I can figure out everything else, okay, because everything else just falls into place. So first I'm going to label my tick marks. I've got -5 pi, -5/2, -5/4, and -15/4 pi. Then I've got 5/4, 5 pi over 2, and 15 pi over 4. And that's all we're going to graph on. Okay. I'm going to draw, well, I mean, you could just go ahead and jump straight to your cosecant wave using the sketch over here. I know that my cosecant wave at -5 pi over 4 has a minimum. And I know I have a vertical asymptote at 0. And then I have another vertical asymptote at -5 pi. Oh, because the vertical asymptotes are the same when you shift it only over 2 tick marks, because you just, where this was, this was here, now it's there, which means you'll have another one like this right here, so the vertical asymptotes will actually stay the same because we shifted it over half of the period. And so okay, here we go. -5 pi over 4, we got a minimum. Just come down, have a min, go back up, and there you go. At -15 pi over 4, since this is a minimum, this is going to be a maximum. And then this is going to be a maximum as well. And then this is going to be only half of a minimum. Something like that. And there we go. Okay, sorry for the confusion on the period. I don't know why I did it that way. But anyway, so you got those 3 problems for homework, and we'll probably practice a little bit more of cosecant and secant together next week when we come back. Okay.